This is the Math 1401 Zoom meeting for 12 p.m. on April 8th. And we're going to work some more problems from section 8.1. I think we pretty much worked through everything through problem 19. So why don't we start in with 21 and then maybe 23. Got a little nastier numbers. This is off page 377, 8.1, problem 21. And the reading speed of second grade students has a mean of 90 words per minute with a standard deviation of 10. And part A, find probability. A student will read greater or more than 95 words per minute. And notice once again, absolutely no mention of sampling or sample size. I don't know why my screen is something strange going on today. Really faded, but you can see the black line, at least I can. Okay, no sample size given. This is out of 7.2. So mean of 90 in the middle, standard deviation is 10. 95 bigger. We want probability a student will read more than 95. So our z-score, 95 minus 90 divided by 10. X minus mean divided by standard deviation. No sample size given. We don't have to worry about dividing by the sample size. You can almost do that in your head. It's 5 over 10. That's 0.5, a half. 5 over 10 is a half, or 0.5. O we'll use. Split off the 0. Table says 0.6915. Barely. I do not know why my Wi-Fi is so faded today, but it says, hopefully everybody knows how to look it up, 0.6915. 0.6915. Answer though, the probability would be 1 minus. The right side trick. It's blurry. 1 minus 0.6915, 3005, 3085, 30% chance. Charge into anything more. So straight out of chapter 7, forwards word problem. When you go to part B, the sample size is now 12. And you want more than 95. So it's the same question, but the sample size is now 12. B, n equals 12. Find probability you're greater than 95. In the middle, standard deviation is 10, greater than 95. And now your z is 95 minus 90 divided by 10, but that's corrected by dividing by the square root of the sample size. You put parentheses here and parentheses here. I'll trust y'all can punch that. 95 minus 90 divided by parentheses and divide by the square root of 12. 1.73. Split that 3 off. 1.7, I won't even try to put the table up. Apparently it's not working today. Looking in the table, 1.73 is 0.9582. That would be this way. Answer, probability would be 1 minus 0.9582. Oh, 0418. 4% chance that the mean of a sample of 12 would read greater than 95 words per minute. Guess we'll just keep working our way down through the parts. Part C, now it's a sample of 24. And the same question, find greater than 95. 95, sorry. You can keep drawing the same picture. After a while, you find the simple variation in it, 90 again in the middle, and standard deviation of 10, and we want greater than 95. And so your Z would be 95 minus 90, 10 divided by the square root of 24. Calculate for parentheses around the 24. If you're really slick, you can, well, if you want to keep it in the second inner, you should be able to work your, yeah, there we are. Work our way back. Sorry, that's so blurry. And then you can work your way to the 12 and make it 24. I went too far. 24. 2.449, I'll call that 2.45. See, 95 gets further and further away from 90 in terms of standard deviations when you sample. That's sort of the point of this. Split off the 5. 2.45 comes up 0.9929. 9929, which again is this way. In effect, 95 becomes at the point at which 99% are lower when with a sample of 24. And so our answer, probability keeps getting smaller. This is shrinking. Our probability gets smaller and smaller and smaller. 1 minus 0.9929. That. I think that's 0071. .7% chance that a random sample of 24 would have a mean greater than 95. So the probability and this area, this tail, keeps shrinking, shrinking, shrinking when you start sampling with higher and higher sample sizes. D. Well, you can see in D, I'll rewrite the answers to A, the answer was 0.3085. B, well, right over here, B, the answer went down to 0.0418. And C, the answer went to 0.0071. And so the answer to D what effect does increasing the sample size have on the probability? And the probability decreases. It says provide an explanation. The best explanation is decreases because the sample size increases. Oops, get that on. Finally, E, we have a teacher who instituted a new reading program at the school. After 10 weeks in the program, found that the mean reading speed of a sample of 20 was 92.8. What might you conclude based on this result? Well, that's worded very, very vaguely. Basically, my answer says that the probability of the mean being greater than 92.8 was 0.1056, so the program's not effective. I'm not sure how you're supposed to read that out of what they've written here. What you would need to be effective. That seems really strange. We'll just cross E off. Now F. There is a 5% chance that the mean reading speed of a random sample of 20 will exceed what value? All right, F is a backwards word problem. Okay. Let me rewrite it so I get a full thing. So this is page 377, 21F. There is a 5% chance that the mean reading speed and I'm going to shorten it up a little bit, n equals 20 will exceed what value? So the picture of this, again, exceed what value, it's going to have to be on the right side. And you're going to want a point X where you'll have 0.05 to its right. And mean in 90 in the middle, standard deviation of 10. All right, so we're looking for the spot where 5% exceed this value. In effect, it's the 95th percentile. Whatever number of reading speed this is. All right. We're going to have to, if you remember chapter 7, backwards problems, you're going to have to look up 0.95 backwards. We come down here and we're going to look up 0.95 backwards. I see a 9505. Again, I'm sorry you can't really see this on the screen. I don't know if I can zoom in. I just so wow, it's been working perfectly, and today I don't know what's going wrong. There's a 95. I don't know if you can barely. Nah, you can't really even see that. That's a 9505 and a 0.9495. This is an equidistance. 5 below, 5 above. I'm going to pick this on the grounds it matches the most digits. So at 9505, my Z is 1.65. If you remember how we worked backwards problems, X minus mean divided by standard deviation. But remember, that is corrected for sample size. May not finish this on this page. So that means my 1.65 for Z x minus 90 divided by 10, which is divided by the square root of 20. And I'm going to multiply both sides by this 10 divided by the square root of 20, 10 divided by the square root of 20 here, and then add 90. Let's see if you can follow this, which means that I'll get 1.65 times 10 divided by the square root of 20 equals x minus 90. And I'll add 90. So 1.65 times 10 divided by the square root of 20, add 90 will equal x. I'm not going to bother to show the screen. Hopefully y'all can punch it. 5 times 10 divided by the square root of 20 and add 90. 93.7, I guess. 93.7 words a minute, you've got 5% bigger. Questions about that? All right. Well, there's one more odd one. I guess I'll charge in. We're only 15 minutes in, so I guess I'll charge into the next odd one. I don't know if this will help anybody or not. This one's got nastier numbers. It's about rates of returns in stocks. And we get a little bit of stockbroker lesson here. Called the S&P 500. That's the Standard & Poor's 500. Is a collection of 500 stocks of publicly traded companies. This is page 377, number 23. For using the data from Yahoo Finance, monthly rates of return are normally distributed. The mean rate of return, yeah, a lot of digits these numbers. So the mean rate of return, we're going to use 0.007233. And standard deviation, 4135. What is the probability a randomly selected month has a positive rate of return? So they try to help you out by telling find that your x greater than 0. Okay. If you picture this one's a little nastier to do, but your 007 is in the center. 0 is this side of it. So it's all of this. That would have a positive rate of return. You'd be making money. This side, negative rate of return, you are losing money. Your value of whatever your stock portfolio is going down. All right, well, your Z is going to be 0.007233 subtract 0. I am so sorry. You always go this is your x. You always go your x minus mean divided by your standard deviation. And notice there's no sampling. Let's try again. I want 0. Yeah, it's got to be a negative Z. 0 minus 0.007233. 0.04135. Okay, this fits the pattern of the other problems. No sampling has been mentioned. So all I really got to do is go negative 233 and divide by 0.04135. And I get negative 0.175. I'll call that negative 0.18. Split off the 8. Negative 0.18. 0.4286. Which should be this direction. Answer minus 0.4286. 5714. 57% chance of making money, getting a positive rate of return. Now, what they're going to do in the next parts is they're going to more than likely keep the same scenario, but add a sample size, which is going to divide that standard deviation by their sample size. We can walk through some of the parts here. Next 12 months is a simple random sample. Therefore, the sample size is 12. So 23 part B, 377. Next n is 12. Probability, you'll be positive. So in other words, probability, they switch it to X bar, your mean is positive. Mean in the next 12 months is positive. And we are going to work it exactly the same way, 0.07233. 0.04135, and again, 0 here. So your Z is 0 minus 0.07233 divided by 0.04135, which is divided by the square root of 12. So if you can call it back or find it. Your top is still negative 0.007233, dividing by parentheses 135, which is divided by the square root of 12. I'm getting negative 0.606. I guess we'll call that negative 0.61, put off the 1. Can you see here? Okay. Negative 0.61. 2709. Just this direction. Again, we're trying to find this. And our answer, 1 minus 0.2709. 7291. So in the next 12 months, 72% chance having a positive rate of return. And I think in C, they change it to 24, and then I think in the next part, 36, don't they? Next 24 months, and then D, next 36 months. And so use the results to describe the likelihood. Without that, we can shorten it up a little bit. If you look at C, N is 24. All right, all you're going to do is change this 12 to 24. I'll write it out. Your Z would be your 0 minus 33 divided by 0.04135, and that's divided by the square root of 24. And you can just call it back if you find it. Make the 12 a 24. Negative 0.857. We'll call that negative 0.86, split off the 6. 1949, or let's say the table value. Our answer is 1 minus 1949. 8051. 80% chance. And you see the probability going up and up as your time horizon goes out. That's what they're getting to in Part E. If we cram on Part D, your N is 36. So your Z, 007233 divided by 0.04135, which is divided by the square root of 36. You can call it back and find it. You keep hitting center and enter, and you'll eventually get back to it. 36. Negative 1.05, split off the 5, and the table says 1469. So your answer, probability equals 1 minus 1469. 8531. So you go to E and it says use your results from parts B to D to describe the likelihood of earning a positive rate of return as the investment time horizon increases. Yes, your probability of earning positive rate of return increases as time horizon increases. And as increases. Oops. That's all the odd ones we assigned. There's some even ones here, but I don't know if y'all interested in them. Look for quiz 8 available tomorrow. Do Sunday 11, 10, true or false questions. Answer on the Google form. All right, we will see you next week. Next week, section 9.2. We have 3 more sections to go. 9.2, 10.1, 10.3. And we can put this semester in the history books. All right, we'll end the meeting. Thank you.